In addition to the integral tables that we've been talking about in the last couple of lectures, uh, there are also pieces of software called symbolic processors or symbolic processing engines that can find indefinite integrals. You give it the function that you want to integrate, and you click on the go arrow or button. Thinks about it for a few seconds and hands you back the integral of that function. There are three really kind of big players in the field. There's Maple Mathematica and MATLAB. I've got their websites here if you'd like to go and take a look at them. They are well-established companies. I was using all three of them 30 years ago, back when I was in grad school. So they've been around for quite a while. These are mature pieces of software that all of these companies have developed. They can do some really amazing stuff. Now, the downside to this is that they are all on the pricey side. However, I believe all of them have some kind of student licensing, where if you can somehow prove that you're a student, either with a student ID card or something like that, and you agree only to use the software for educational use, then you can get it at a discounted price. Now, there is another option here. There's another website. Right? Again, you can click on that link, go here if you want to take a look at it. It's an online integral calculator. And you can tell from the name, right, if you compare it to the URL for Mathematica up there, these are both done by the same company. Right? So if you go to this website, and I have to be a little careful what I show and do here because I don't want to run into licensing issues. So I'm not going to actually try to use the software here. But if you go to that math link, you'll get a page that looks similar to this. This is their online integral calculator. You can enter the function that you want to integrate in that little box there using all of these various icons. Enter the function that you want to integrate, click OK or the little arrow there at the end, and it'll give you the integral of your function. And if you look closely at these toolbars, you'll see that it can actually do a lot more than that. This is the DDX. That's the symbol for a derivative. So it can find the derivative of functions. It can do some limits down here. And if you look at some of these things, this is the one you would be using to do an integral. But if you look at the one next to it, it looks a little weird to you, right? That's the same thing, but there's two integral signs. And then this one here has three. So those are what are called double and triple integrals. And if you continue on after this class and you go into the third semester calculus class, that's where we'll be talking about those operations as well. These over here, what are called partial derivatives. And so this is a pretty sophisticated piece of software. Can do an awful lot of stuff for you. Now, I said this when we first started talking about tables, and I'm going to say it again now because it bears repeating. I realize that I'm pointing you to tools that will do your homework. All right. If you're inclined to use these tools to do your homework, then you're seeing your homework as just a box that needs to be checked off. And I'm going to be just very blunt about this. If that's the way you're thinking about the subject, this is maybe not the subject for you. If you're using these tools, you should be using them to check your homework. Or sometimes you can look at the result, and if it's different from yours, you can kind of get a hint as to how you should proceed to solve that problem. In fact, I'll tell you, I use this particular website right here regularly as I'm developing this class, as I was developing this class, just to check my results. Because some of these integrals you see as we get further into this chapter, the calculations are long and kind of messy, and even the answers are kind of messy. So, it was nice to have something just to validate my work and make sure I didn't make some crazy mistake that threw the whole thing off. One thing you need to be aware of when you're using tools like this, the answers that you get may not always match yours, and that doesn't mean that you did it wrong. All right, so for example, this is an integral that we're going to take a look at and actually do by hand later in the class. If you go to that Wolfram Alpha website and ask it for this integral, you're going to get this expression right here. Now, when I did this by hand, I got this expression, and if you compare them closely, you'll see that they're different, right? The logarithm part of my answer has this fraction here. Now, when you see something like this, don't immediately jump to the conclusion that you did something wrong. You may have just not gone as far as the website did. So, for example, with this question, look, if I did this, if I factored out that 1/5, this becomes negative 25/6 times the log of 1/5 square root of 9x squared minus 25 plus 3x. Now I can use some logarithm rules here. This is minus 25/6, all right, that got messy, minus 25/6 times the log of 1/5 plus the log of this square root of 9x squared minus, sorry, I can't write 2's today, square root of 9x squared minus 25 plus 3. Okay, now let's distribute that minus 20. Obviously, I'm just focusing on this part. This part would continue to come on down here. But if I distribute this, this is negative 25/6 log of 1/5 minus 25/6 log square root 9x squared minus 25 plus 3 plus a constant. I get this constant part in here. Now look at this bit here. That's a constant, right? So if I add this constant to my constant down here, I get another constant. So let's combine those two together, call it a new constant d, and all that's left now is minus 25/6 log of, and I didn't leave myself enough room, log of the square root of 9x squared minus 25 plus 3x, and I'm going to slip the x that I left out back in there. Closed all my parentheses, plus a new constant d. And now if you compare this to this, yes, they are the same thing. Right? So this answer up here was perfectly good. And in fact, if this were a test or something, I would accept that as an answer. Right? But you could go a little further. Or you could simplify it a little further, and that's how the website came up with its answer. So just because your answer doesn't match, like I said, don't immediately jump to the conclusion that what you did was wrong. You may just need to do some more manipulation and transformation to get your answer to exactly match what the website was ending up with. So before we end our discussion of table and processes, software-based methods for finding integrals, and get back into the actual mechanics of doing these things by hand. In the next lecture, I'm going to talk for a little bit about a special kind of markup language, right, that's used to type mathematical symbols and equations. Right? So if you type something out in this markup language, and then you enter it into a piece of software that can interpret it, that software will take what you typed and turn it into a very nicely formatted mathematical expression or equation. This is a really useful tool to have in your toolbox if you plan on really pursuing any kind of math or science related field. It's especially useful at this point in your mathematical life for using things like that Wolfram Alpha website. As someone who can type really quickly, having to constantly take my hand away from the keyboard to take the mouse and go and click on something and then put my hand back on the keyboard, back and forth, clicking and switching around, is very tedious. It feels like I'm just massively slowed down. Once you get the hang of the basics of this markup language, you can type out equations much more quickly than you can by using that kind of graphical editor thing like you saw on the website. That's what we're going to cover in the next section.